It's 1666. A young man sits under an apple tree in the English countryside, hiding from the plague. An apple falls, and instead of brushing it off and thinking, he takes it straight to the skull. He collapses. He never wakes up. The man who was supposed to rewrite the laws of the universe, dead at 23. And with him, gravity, calculus, the laws of motion, all of it, erased before it was ever written. To understand what we lost, you need to know what Isaac Newton actually did. Born in 1642 in Woolsthorpe, Lincolnshire, Newton was unusual, to say the least. As a student at Cambridge, he wasn't the flashiest mind in the room. But when the plague closed the university in 1665, he went home. And in 18 months of total isolation, he basically invented modern science. He worked out calculus, the mathematics of change and motion. He split white light into a rainbow using a glass prism. And yes, somewhere in that very productive quarantine, inspired by a falling apple, not necessarily hit by one, he started thinking seriously about gravity. By 1687, he published the Principia Mathematica, arguably the most important scientific book ever written. It explained how objects move, why the planets orbit the sun, and gave us the formula for gravitational force. Everything humanity would build for the next 3 centuries rested on Newton. But what if the apple didn't inspire him? What if it ended him? Summer, 1666. The apple falls. Newton takes a direct hit. Blunt force trauma, hemorrhage, gone. No recovery. No Principia. Just a quiet grave in Lincolnshire, and a footnote that reads, "Showed early promise." The world moves on, not knowing what it just lost. First ripple, calculus. Newton invented calculus at almost exactly the same time as the German mathematician Gottfried Wilhelm Leibniz, and they had a very famous, very petty feud over who got there first. Without Newton, Leibniz publishes in 1684, and calculus still exists. So math isn't entirely gone, but Newton's version came bundled with something Leibniz didn't develop nearly as fully, a physical framework to go along with the math, the mathematics of motion tied to actual motion. Without the Principia, physics stagnates. Leibniz's calculus gets used mostly for abstract mathematics and engineering problems, but nobody has the conceptual framework to unify the heavens and the earth. The idea that the same invisible force pulling an apple to the ground is also holding the moon in its orbit, that insight doesn't come from Leibniz. It doesn't come from Robert Hooke, who was circling the answer but couldn't quite land it. It doesn't come from Halley or Wren or any of the other brilliant minds of the era. So in this timeline, someone else eventually figures out gravity. The laws of physics don't change just because one person dies. But when? Conservative estimate, something like the Principia gets written sometime in the 1740s, maybe the 1750s. That's a 50 to 70 year delay at the single most critical moment in the history of science. And delays, as it turns out, compound. Let's talk about what needs Newton to exist. The Industrial Revolution begins in Britain in the 1760s. It's not a purely Newtonian project, the steam engine, the spinning jenny, the power loom, but the engineering culture that made all of those possible was completely soaked in Newtonian mechanics. Without the Principia, the mathematical training of engineers looks very different, less precise. The feedback loop between scientific theory and machine design takes much, much longer. Does the Industrial Revolution still happen? Yes, probably. Economic pressure alone would eventually push it forward, but our best estimate in this timeline, a 30 to 40 year delay. So instead of the 1760s, we're looking at maybe the 1890s, maybe later. And if the Industrial Revolution delays, everything downstream delays with it. Thermodynamics, the science of heat engines, of efficiency, of energy itself, was built on Newtonian foundations. Delay that, and you delay Carnot, Clausius, Kelvin, Maxwell's equations, unifying electricity, magnetism, and light in 1865, pushed back to 1895 at the earliest, maybe beyond. And here is where it really cascades. Einstein in 1905 published special relativity partly as a correction to classical Newtonian mechanics. Without Newton's framework as the baseline, without that specific problem to solve, the path to relativity bends in completely unpredictable ways. Nuclear physics depends on quantum theory. Quantum theory depends on electromagnetism. Electromagnetism depends on thermodynamics. Thermodynamics depends on Newton. The atomic bomb? If it even happens, it doesn't happen in 1945. World War II, if it takes the same shape at all, doesn't end the same way. The moon landing in 1969? Not in this century, possibly not the next. So here's the alternate world by the year 2026, which, just so you know, is today. Technology roughly equivalent to our 1930s or 1940s. No internet, no satellites, no GPS. Possibly, and this one stings a little, no nuclear weapons, which is genuinely not entirely bad. The global population is smaller. Without modern medicine, which depends on the entire scientific chain we just broke, childhood illness kills far more people. Cities are quieter, slower. The sky has more stars because there aren't enough satellites to clutter it. Someone, eventually, discovers everything Newton discovered. The apple still falls. Gravity still exists. The laws of motion are still there, waiting. But the timeline of human civilization shifts by roughly a century, maybe more, all because an apple fell a few inches to the left. One man, one afternoon, one moment of being in exactly the wrong place at exactly the wrong time. Newton once wrote, "If I have seen further, it is by standing on the shoulders of giants." In this timeline, he never got the chance to stand on anyone's shoulders, and 4 centuries of scientists never got the chance to stand on his. The apple didn't fall to reveal the laws of gravity. The apple fell and took them with it. If you want to know how fragile progress really is, now you do.